Earthquakes, nature's most fearful disasters. Over 2,000 earthquakes were recorded and measured on Earth, some as close to the 10.0 magnitudes in Japan. All earthquakes occur at the tectonic plates of the Earth that connects most of the continents together. Earthquakes are measured by a tool called seismographs. Seismographs measure the waves released by an earthquake, first the P wave and finally the S wave. First, the P wave, known as the fastest and primary wave, is released from the epicenter of the earthquake. Next, the S wave, the most strongest and destructive wave, is released from the epicenter of the earthquake. The ground sways up and down, which causes damage to buildings and other infrastructure. Severe loss and many deaths can occur. The crust is a very thin layer over many layers of molten magma. Earthquakes are mainly caused by convection currents in the Earth that cause tectonic activity to occur in any plate boundary on the Earth, forming and moving continents across the ocean. Volcanoes are also caused because of the convection currents in the Earth. The less dense plate subducts down into the asthenosphere and causes magma to rise up to the volcano, which then results in catastrophic volcanic activity. Earthquakes also cause tsunamis if they were to be underwater. Most tsunamis are generated by shallow, great earthquakes at subduction zones. When a great earthquake ruptures, the faulting can cause vertical slip that is large enough to disturb the overlying ocean, thus generating a tsunami that will travel outwards in all directions, says IDIC.org. Most tsunamis are generated by earthquakes with magnitudes over 7.0 that occur under or very near the ocean and less than 100 kilometers, 62 miles, below Earth's surface. Earthquakes deeper than this are unlikely to displace the ocean floor.
You're looking at a building that you would find in any part of the world. And for reasons I don't understand, we as a society have decided to build buildings out of stacks of cubes. Now the problem is that cubes have no structural integrity. And by that I mean that no matter how well I bolt this building to the ground, no matter how strong its columns and its beams are, this building is held up exclusively by its corners. It's only as strong as its weakest corners. Now what an earthquake does principally is move the ground from side to side, and you can see how weak this building is. Many earthquakes also move the ground up and down, and again this building is very weak. And all earthquakes produce torsion, twisting motion, and you can see this building is extremely weak. If any one of these corners breaks, this building is coming down.
Earthquakes have affected many lives and countries, and will continue so. The kneel and duck method is very supportive to survive an earthquake in schools and other public places.